Good morning. In today's class, we will see calculating coefficients of generating function. Now, till now, whatever topics we have seen of generating functions, we were interested in solving permutation and combination kind of problems. So, all the combinatorial problems were solved using generating functions. So, whatever generating function we have used till now, we solved combination problems, that is selection. But now, what we will do is we will develop a few algebraic techniques for calculating the coefficients of our generating function. So first and foremost, before we begin the topic, we have to know the concept of division of the generating function, or as we generally say, division of formal power series. Division of formal power series. Now, suppose if so for this, if a of x, it is given as sigma n is equal to 0 to infinity e n x power n. If this is a generating function or a formal power series, then a of x is said to be multiplicative inverse. If there is a formal power series, so a of x is a multiplicative inverse. If there is a formal power series, b of x, what is b of x? It is another formal power series, k is equal to 0 to infinity bk x power k, such that a of x into b of x is equal to 1, or we can even say that b of x is equal to 1 by a of x. Okay, so that is, we can write a of x as 1 by a of x, and whenever we multiply these two series, then the the resulting the resultant value should be equal to 1. So this can be taken directly as a definition. The results of these definitions are important. That is, we will see the further we will see further formulas which are important from this definition. The next definition with respect to this topic is, this is your definition 1. Okay, now the next definition is definition 2. If a of x and c of x are power series, we say that a of x divides the c of x, if there is a power series d of x, if there is a power series, so another power series d of x, which gives us such that c of x is equal to a of x into d of x. Okay, so a of x is dividing c of x. If we have this d of x, or we can even say that there is the remainder when you divide these two series. So when you divide c of x by a of x, you will get another series d of x. Of course, for these, we have to take arbitrary formal series, and also if a of x divides c of x, then we can say that a of x also has a multiplicative inverse. Okay, so if there is exists 1 by a of x, then we can divide c of x by a of x. Okay, so now based on this, we will see a few formulas The first one and the most important one is, it is also known by the name of geometric series. It is given as follows: 1 by 1 minus x is equal to r is equal to 0 to infinity x power r. So this 1 by 1 minus x is equal to x power 0 will be 1 plus x square plus x cube and so on up to infinity. This is the most important formula of this chapter. Very, very important, need to be remembered that 1 by 1 minus x is equal to r is equal to 0 to infinity x power r, or it can also be written as 1 plus x square plus x cube and so on. Now, in this formula, if I replace x with ax, so replacing x with ax, where a is a real number, then 1 by 1 minus ax is equal to r is equal to 0 to infinity a power r x power r. This geometric series is with the common ratio a. So this is also a geometric series, but here the common ratio is a. Okay, 1 by 1 minus ax, r is equal to 0 to infinity a r x power a power r x power r. Now, suppose instead of this a, I am taking a value as minus 1. Let's take a is equal to minus 1. So this will become minus of minus x plus x. So let's write the formula now. 1 plus x is equal to r is equal to 0 to infinity minus 1 power r into x power r. Now, first minus 1 power 0 into x power 0, anything power even value will be positive, so 1. Now, what is the value of r is 1? R is equal to 1. Minus 1 power 1, it will be minus 1 into x power 1, so minus x. Then r is equal to 2. It will be positive x square minus x cube and so on, plus and so on. Now, this series is called the alternating geometric series. So this is known as alternating geometric series. So the first one was our simple geometric series, that is all positive signs. Then this is the general formula. We can have any value of a. Then it can be written as 1 plus ax plus a square x square plus a cube x cube and so on. Now here one positive, one negative term is the alternating geometric series. Okay. Now based on this, we will have the formula for 1 minus x whole power minus n. 1 minus x, that is, this is called 1 minus x whole power minus n, or it can also be written as 1 by 1 minus x whole power n. So normally we know what is 1 plus x whole power n. What is that? This is our binomial theorem from our earlier chapter. So binomial theorem is defined as 1 plus nc naught, not 1 plus nc naught into 1 power n x power 0 So I'll just directly write, please refer to the formula, or I can write the formula here. X plus y whole power n is nc naught x power n plus nc1 x power n minus 1 y power 1 plus and so on up to ncn y power n. So this way, if I write for this, instead of x I am taking 1, instead of y I am taking x, then it will be nc naught plus nc1 into x plus nc2 into x square and so on till ncn into x power n. But here, instead of positive power, we have negative power, and this is actually known as extended binomial theorem. Extended binomial theorem. And for this, directly if I want to explain it to you, extended binomial theorem is given as follows. R is equal to 0 to infinity. Since this is in the same way as 1 by x or the geometric series, here we have, suppose n is the power, then we will have n terms. But if we have minus n as the power, we will have infinite terms. And it will be written as n plus r minus 1 cr into x power r. N plus r minus 1 cr into x power r. Okay, this is a formula for extended binomial theorem. Remember it, better to remember it as a formula. Now instead of minus x, if I take plus x, I will have 1 plus x whole power minus n. It is given as r is equal to 0 to infinity c of n plus r minus 1 cr minus 1 power r into x power r. So both of these are formulas to be remembered and quite important. So let me just segregate it. So yeah, these two are extended binomial theorem formula. If we have 1 minus x whole power minus n, it will be r is equal to 0 to infinity n plus r minus 1 cr into x power r. Instead, if we have 1 plus x whole power minus n, then we will have r is equal to 0 to infinity n plus r minus 1 cr into minus 1 power r into x power r. Okay. Now similarly, based on this, if I want to define 1 by 1 minus ax whole power n and 1 by 1 plus ax whole power n. So what I will do, this term will remain as it is, r is equal to 0 to infinity n plus r minus 1 cr. Here, since we have a, I'll add an additional a, ar x power r. Okay. So for this, we add ar x power r. Similarly, for this, I will take, instead of minus 1, I will take simply minus a. Or you can take minus 1 power r into a power r. But directly it is better to take minus a power r. So for these two, this is the formula, and the earlier ones that I did not mention a is the formula for 1 minus x and 1 plus x. Okay, don't get confused. Make sure you have written this formula first, and then again add a in the already existing formula, and then you will get the following formulas. Now, instead of, in our first formula, that is geometric series formula, this one, instead of x, suppose I am substituting x power k. Okay, x power k. So instead of this x, I have x power k. What will be my formula? R is equal to 0 to infinity x power k whole power r. Okay, or you can write it as x power kr. Okay, now when I expand it, r is equal to 0 to infinity, it has to be written. Now, what will be r is equal to 0 if I put k into 0, x power 0, so 1 plus x power k into 1 when r is equal to 1, so x power k plus x power 2k plus x power 3k and so on up to infinity. Okay. Now, after that, suppose if I have 1 by a minus x. So in this case, what I can do is take this 1 by a outside, then I will have 1 by 1 minus x by a. So again, instead of x, I have x by a, and 1 by a is a constant. So 1 by a into sigma r is equal to 0 to infinity x power r by a power r. So this is also an important formula which I will actually use in the topics of recurrence relations. So this is an important formula. Suppose if we have, instead of 1 by a minus x, I have 1 by x minus a. What we are supposed to do is simply take minus common, convert it into this, and again here you will have a minus, and this will remain as it is. Okay. Also, another important formula is 1 plus x square plus and so on up to x power n. This is very, very important. 1 plus x square plus and so on up to x power n. So instead of the infinite series, so if I have infinite series, it will be simply 1 by 1 minus x. But instead of that, I have 1 plus x square, it is ending at some nth term. Then what will it be equal to? It will be equal to 1 minus x power n plus 1 by 1 minus x. Okay. So this is also quite important. Remember this. Please make sure that you note down all the important formulas on a white A4 size paper so that it is easy to remember when you are revising. Similarly, I'll just write the binomial theorem formula. So that is, if n is a positive integer, then I'll write a set of formulas which you can actually take by which you can actually get by using binomial theorem. But here let's just summarize it. 1 plus x power n, 1 plus x power k whole power n, 1 minus x whole power n, 1 minus x power k whole power n. Now, this I have already written 1 plus, or nc naught, you can say nc naught plus nc1 into x plus nc2 into x square plus and so on up to ncn into x power n. Okay. Now, the next one, instead of x, I have x power k. So here each time I will write x power k, x power 2k, x power nk. So let's write the same. nc naught plus nc1 into x power k, 1 into k. So k, simply k. nc2 into x power 2k plus and so on up to ncn into x power nk. Okay. Now, the next thing is, similarly, instead of plus x, now I have minus x. So nc naught minus nc1 x power 1 plus nc2 into x square, alternating positive and negative signs. Similarly, for this also we will have x power k, and here alternating positive and negative signs. So these are all special cases of binomial theorem, very similar to binomial theorem. The next topic is use of partial fraction decomposition. So I believe you have already studied partial fractions in mathematics. We will be using the same concept, and instead we will, at the end, we will try to convert the partial fractions into generating functions. So let's see an example. The question is, calculate b of x is equal to sigma r is equal to 0 to infinity dr into x power r, which is given as 1 by x square minus 5x plus 6. Okay, so basically this is the question. 1 by x square minus 5x plus 6 converted into partial fraction. So first we have to factorize it, I believe. So let's factorize it. it is written as x square minus 5x plus 6 can be written as x minus 3 into x minus 2. Now, we usually when we are doing partial fractions, we will take some constants a and b and write this as a by x minus 3 plus b by x minus 2. Now, to find this a and b, what we will do is we will multiply both sides with this term, cancel it, and write it in this way. So, a into x minus 2 plus b into x minus 3 is equal to 1. So, I am not going into the detail of partial fractions, the reason being you have already studied it in mathematics. Now, suppose to find a, we will take x is equal to 3. So let x is equal to 3. Then when you substitute x is equal to 3, this part will become 0. 3 minus 2 is 1. So a is equal to 1. Then a is equal to 1. And then let x is equal to 2 to find b. Similarly, we will get b is equal to minus 1. Okay. Now, after that, substitute the a and b values. So instead of this a of x minus 3 plus b of x minus 2, we will get 1 by x minus 3 and minus 1 by x minus 2. Okay. So let's write that. 1 by x square minus 5x plus 6 is equal to 1 by 3 minus x. Now I'll tell you the reason why I am writing it as 3 minus x. Minus 1 by 3 minus x. So what I am doing is 1 by x minus 3 I am multiplying it with a negative sign both on the numerator and denominator because I want it in the form 1 by 1 minus x or 1 by a minus x. Okay. So to get it into this form, I multiply the numerator and denominator with minus 1. Here, since b is already negative, we will have 1 by 2 minus x. Okay, so 1 by 2 minus x. Now after that, if you remember, I said that 1 by a minus x, I'll take this a outside. So 1 by a into 1 by 1 minus x by a. So this can be written as 1 by a into sigma r is equal to 0 to infinity x by a whole power r. So the same way here we will take this minus 1 by 3 and then we can write this as r is equal to 0 to infinity 1 by 3 power r into x power r. So 1 by a power r into x power r is the same way, and this can be written as 1 by 2 r is equal to 0 to infinity 1 by 2 power r into x power r, or you can even write x by 3 power r, no worries. Now after that, since we are supposed to find the coefficient, or we are supposed to write it as the form of a generating function, r is equal to 0 to infinity minus 1. Now this minus 1 by 3 and we have over here 1 by 3 power r. So this can be written as 1 minus 1 by 3 power r plus 1. Similarly, this can be written as 1 by 2 power r plus 1 into x power r. That is, I am taking x power r common. Since the sigma notation is the same, that is from r is equal to 0 to infinity. So we can write this as common, and then I am writing the entire term in the form which is easy to be written or read. Now, what is the coefficient of x power r? For each x power r, the coefficient will be this entire thing. That is, therefore, for each r, dr is equal to minus 1 by 3 power r plus 1 plus 1 by 2 power r plus 1. Suppose x power r, if we want to find the coefficient of x power 0, here we substitute r power 0, r is equal to 0, then we get the coefficient of x power 0. Similarly, for x power 1, substitute r is equal to 1 in both the places and we will get the coefficient. So, if we notice the question, it had calculate b of x r is equal to 0 to infinity br into x power r. So, what is our br value? The br value is the following. Okay. So now similarly, you can do various other kind of problems which will be given in the exercise. Now the next important type of question that you usually get is find the coefficient of x power 20 in x cube plus x power 4 plus x power 5 and so on up to infinity whole power 5. Now we have to find the coefficient of x power 20. So for x power 20, first we have to simplify this bracket. So to simplify this bracket, what we can do is take x cube common. So let's write the solution. Extract x cube from this bracket. So let's write it x cube into 1 plus x square plus and so on up to infinity whole power 5. Now x cube power 5 will be x power 15 into what is this 1 plus x square? This is written as r is equal to 0 to infinity x power r whole power 5. Now this x power 15 is as it is. What is this? It is basically formula for 1 by 1 minus x. Okay, don't mention this in this way, but it is the formula for 1 by 1 minus x. So x power 15 divided by 1 minus x whole power 5. So this can be written as x power 15 into 1 minus x whole power minus 5. Now for this we have to use extended binomial theorem. This is extended binomial theorem formula. What is the extended binomial theorem formula? If we have 1 minus x whole power minus n, always mention the formulas on the side of the paper so that it is either on the side or wherever you are using it, just mention it in brackets so that it is easier for the examiner to correct your answer sheet based on the formula that you are using. So what is the formula for 1 minus x whole power minus n? It is given as r is equal to 0 to infinity n plus r minus 1 cr into x power r. So here this can be written as x power 15 into r is equal to 0 to infinity 5 plus r minus 1 cr into x power r. Now what should we multiply x power 15 with? What value of x power r should we multiply x power 15 with to get x power 20? So this is the basic thing. A power m into a power n is a power m plus n. So a power m is 15. What should we add to 15 to make it 25? So what will be the value of r? The value of r will be 5. So let's take the value of r as 5. Then what is the coefficient? We want the coefficient. So r value is 5. Then the coefficient will be, substitute r over here because this is our coefficient. So substitute r is equal to 5. So 5 plus 5 minus 1 c5 which is equal to 9c5. So this is the coefficient of x power 20. Now similarly you can solve various other kind of problems of the same type. We will see another type which is calculate the coefficient of x power 15 in a of x is equal to x square plus x cube plus x power 4 plus x power 5 into x plus x square plus x cube plus x power 4 plus x power 5 plus x power 6 plus x power 7 into 1 plus x square plus and so on up to x power 15. Now for this, what are we supposed to do first is take x square common from this so that we get it in the form of 1 plus x square and so on. From this also we can take x common, so again we get the first term as 1. So let's solve it. Solution. X square common, if I take x square common, this will become 1 plus x square plus x cube. Okay. Now from here if I take x common, this will become 1 plus x square plus x cube plus, it will go on till x power 6 instead of x power 7. So let's write that. And here it is in the notation of 1 plus x square, so we are not taking anything common. We will keep it as it is, 1 plus x plus and so on up to x power 15. Now, this 1 plus x square plus x cube, if you remember, we have already seen an important formula for this, which was 1 plus x square. If it goes on till some nth power, then the formula is given as follows: 1 minus x whole power n plus 1 by 1 minus x. So let's use that formula. So this can be written as x square into x is becoming x cube. Now instead of these brackets, we are using the formula that I have just shown you. So the formula, here we have x cube. So in the formula we will have 1 minus x power 4 by 1 minus x. Then here we have x power 6, so x power n plus 1 in our formula, so 1 minus x power 7 by 1 minus x. And then again 1 minus x power 16 by 1 minus x. Okay. Now what does it become if we multiply all the denominators? It will be x cube into 1 minus x power 4 into 1 minus x power 7 into 1 minus x power 16 by 1 minus x whole cube. So the coefficient of x power 15 is the same as the coefficient of x power 12. How is that? Because we have x cube already. So whenever we want x power 15, we have to add 12 over here. A power m into a power n is a power m plus n. So over here, this will be, in this we have to find the coefficient of x power 12. So what we are doing is we will take only this part and find the coefficient of x power 12. 1 minus x power 4 into 1 minus x power 7 into 1 minus x power 16. This can be written as 1 minus x whole power minus 3. Apply extended binomial theorem for this part. So it will be here, since we only want the coefficient of x power 12, but if we multiply anything with this equation, we are exceeding our power, that is x power 16 is greater than x power 12. So we can leave this term. Now apply extended binomial theorem as I have shown you earlier. Multiply these two brackets and then take the coefficient of your x power 12. Please try it as an exercise for yourself. And this concludes the topic calculating coefficients of generating functions.